In this video, I'm going to teach you how to sketch polynomial functions. A polynomial can be expressed in terms that only have positive integer components in addition, subtraction, and multiplication. A polynomial equation is a polynomial set equal to 0. In order to sketch a polynomial function, you must know how the function ends, how the function starts, the function's x-intercept or intercepts, and the function's y-intercept. First, let's determine how functions end. The function on the left has a positive leading coefficient, so the graph of this function will end going up because it's an increasing function. The function on the right has a negative leading coefficient, so the graph of this function will end going down because it's a decreasing function. Second, let's determine how functions start. To find a function's degree, count the number of x values in the function's equation. The function on the left has a degree of 1, 2, 3, 4, a degree of 4, so it has an even degree and it starts and ends in the same direction. The function on the right has a degree of 1, 2, 3, a degree of 3, so it has an odd degree and it starts and ends in different directions. Third, let's determine how to find a function's x-intercept or intercepts. To find this function's x-intercepts, set each of the x values in this function's equation equal to 0. The x-intercepts for this function are at these points. Fourth, let's determine how to find a function's y-intercept. To find this function's y-intercept, plug 0 into each of the x values in this function's equation. The y-intercept for this function is at the point 0, 6. Now, let's explore different types of roots. To determine the roots of a function, the function's equation must be fully factored. The function on the left has linear roots and passes through the x-axis at the value of the roots. The function in the middle has a double root and changes direction at the value of the double root. The function on the right has a triple root and has a point of inflection at the value of the triple root. Now let's practice sketching polynomial functions. The first step is to determine how the function ends and starts by examining the function's leading coefficient and degree. This function has a positive leading coefficient, so the graph of this function will end going up. This function has a degree of 3, 5, 6, a degree of 6, so it has an even degree and it starts and ends in the same direction, so the graph of this function will start and end going up. The second step is to plot the function's x-intercept or intercepts. The x-intercepts for this function are at the points -1, 0, 1, 0, and 2, 0, as can be seen here, here, and here. The third step is to plot the function's y-intercept. The y-intercept for this function is at the point 0, 32, as can be seen here. The fourth step is to connect the function's intercepts. The function starts up, changes direction when x is equal to -1, passes through the y-axis when y is equal to 32, passes through the x-axis when x is equal to 1, has a point of inflection when x is equal to 2, and ends up. To summarize, in order to sketch a polynomial function, you must determine how the function ends and starts, then you must plot the function's x and y intercepts, and then you must connect the function's intercepts.